This video will be once again about encoding schemes, UTF, and comparing JavaScript and Rust from this point of view. For this, I have prepared a small emoji that you can see here. As you can probably anticipate, this emoji will require some bytes and some characters. But what I want to highlight in the beginning of this video is how getting the length of this single character differs in JavaScript and Rust. So if I have this emoji, and if I will zoom in a little, if I have this string that contains only this emoji, trying to get the length, we'll get 8. We don't know yet. I mean, I know, but I want to keep some mystery. The value, the length, we don't know yet what it refers to. What does 8 mean? We see for sure one single grapheme. We might suppose that it can be composed of an emoji that contains a man, one that contains a woman, and one that contains a child. And there will be 3, but why does it show 8? That's a question I will like to answer in a minute. First, I want to show you what the result is like in Rust. First of all, for some reason in Alacrity, I cannot get this emoji being shown, but you have to trust me that it's the one that I've copied from here. For some reason, maybe there is some encoding problems with Alacrity, and I haven't got the chance to fix them yet, but you have to trust me that here in this empty space there is this emoji. And by running this command once again, we can see that the number is 5. So it's even more confusing that in Rust we have 5, the char's length is 5, and in JavaScript the char's length is 8. Now, the main difference between them is in what length will return compared to what chars that count will return. First, we have to establish some further definitions, and I will simply write them down here because it seems more convenient than just speaking. The first concept that we have to introduce is code point. This code point is essentially the number that is assigned to each grapheme in the Unicode table. If we look for the Unicode table, we'll see this huge table. To my understanding, the code point is basically this number that can be represented in either decimal, octal, or hexadecimal format. So the code point is the number. It's this one essentially. It's the first column. Now, since we have this in mind, the code point, then we also have the concept of Unicode table, which contains code points. Basically, we have grapheme and so on. And then we also have what's called encoding schemes, which are UTF-8, UTF-16, and so on. UTF-8 is used by Rust, and UTF-16 is used by JavaScript. Now, these encoding schemes are used to represent in let's say in a way that computer understands this code points. So encoding schemes are used to represent graphemes from the Unicode table, and the way they represent and what encoding schemes look at, it is the code point of a specific grapheme. With that in mind, we can also introduce the new notion of code unit. Now let's come back a bit to the encoding schemes. UTF-8 and UTF-16, in those two, 8 and 16, they essentially refer to the minimum number of bytes for each character. Unicode 8, it means that for each character we will have at least 1 byte. When it comes to UTF-16, we will have at least 2 bytes per each character, meaning that even the character A in a UTF encoding scheme, it will require 1 byte, whereas in a UTF-16 it will require 2 bytes, which is not a problem, I suppose. It depends, but this is how things work. Now, a code unit is relative to the encoding scheme. So a code unit is essentially is related to the bytes required depending on the encoding scheme. I know it doesn't make sense yet, but let's take a simple example. It's let's say that we have this let's search for y with brief. This character, I don't know if it is the right example or not, but I will try. This character, it will require 2 bytes in UTF-8, and I think in UTF-16 also 2 bytes, or maybe 1 byte. Let me search for it. In UTF-16. So how many code units? 1 or 2? 1 code unit. So the basic idea that I want to highlight, and I was digressing a bit, is that a code unit is I don't know how to put it now that I have to record this. Essentially, a code unit is for UTF-8 1 byte, and a code unit for a single code unit for UTF-16 is 2 bytes, meaning that this will take 3 bytes in UTF-8, and these 3 bytes, all of them are code unit in the context of UTF-8. However, supposing that this will require, let's say, 3 bytes, or let's say that in the context of UTF-16, this one will require 2 code units, as it said here. So in UTF-16, okay, so it seems that it depends, 1 or 2, but in essence, 1 code unit in the context of UTF-16, 1 single code unit has 2 bytes. So coming back to our initial problem, so once again, the code unit is, just to type this down so that it is marked here somehow, UTF-8 in the context of UTF-8, 1 byte each. In the context of UTF-16, a code unit has 2 bytes each, and this clarification, although I have spent more than desired time on this, this code unit is very relevant because in JavaScript, the length property will return the number of code points. This character is, let me come back to the diagram. This character here, it is composed indeed of 3 emojis: man, so it is man, it is woman, and let me also type emoji, or it is obvious, I guess. And there is also the child emoji. Here we have three. So this emoji is composed of these three. But in order for this emoji to become possible, these emojis, which are self-contained, they need to be joined by some other character. And this character has a special name. It is called 0 with joiner, which is also abbreviated with ZWJ. We can also look for it very quickly. So it says that it is a Unicode character that joins two or more characters together in a sequence to create a new emoji. And if we add this two between these two emojis by, let's say, performing an addition or a combination of all of them, we'll get this. So this is equal to this. Now, the final answer. Why do we get 8 and why do we get 5 in Rust when counting the characters? The fact that JavaScript uses UTF-16, it means that this one, okay, not this type of arrow, it means that this one will, or I will type this right away. So it means that the first emoji, the woman, will contain 2 bytes. The man will also have 2 bytes, its emoji in UTF-16. So it will have 2 code points for, I think I said bytes. No. So the woman emoji has 2 code points in UTF-16, and the man also has 2 code points in UTF-16. The child emoji also has 2 code points in UTF-16. This has only 1 code point, and by making the sum we get 8, which is what the length property in JavaScript returns. So the length property in JS, length returns the number of code points. And if we take a closer look in Rust, chars that count will return the number of code units. This is a code unit, although it is a character, but under the hood there is a code unit, and chars that count will return the number of code units, and in this case there are 5. We have woman, man, and child, plus the 2 joiners, the 2 0 with joiners. So this will give the number 5. Now, one last question: how can we in JavaScript get the number of code units instead of number of code points? For that, we can copy this emoji, and for this we can use the spread syntax. And if we evaluate this expression, we'll get 5, which is, and basically here we can also see the code points: man, the joiner, a woman, joiner, and the child. So I know this video got a bit too long, and I spent more time than I initially expected, but in my view, I think it helped me a lot, because I had to do some research on the spot to, let's say, perform under some pressure, which is a good thing sometimes, if not always. And by trying to explain this to you and to myself, first of all, I feel like things make a lot more sense, and the information has been established more solidly, if that makes sense. And I think now it's it would be very useful to have a very quick recap. So this emoji, by calling length in JavaScript, it will return the number of code units, and the code unit is essentially it is relative to the encoding scheme. If we use UTF-8, one code unit will have 1 byte each. If we use UTF-16, one code unit will have 2 bytes each. Basically, the code unit is a fundamental unit of an encoding scheme, and depending on that code unit will have 1 or more bytes. Coming back to our example, if we call this dot length, the dot length property on string, it will return the number of code points. And breaking down this emoji, we can see that it is composed of 5 code units, which are once again something that a code point is essentially a grapheme, an entry in that Unicode table that we've seen here. And now coming back again to the length property, it will return the number of code points. Basically, it will take each code unit and see and check based on the encoding scheme how many code points are needed for this current code unit. For the woman emoji, there are 2 code points. For the 0 with junior, there is 1. For the man, 2. For the 0 with junior, once again, is 1. And lastly, for the child, there will be 2. And if we sum up, we'll get 8. And this is why this will return 8. In Rust, by using the chars that count, we'll get the number of code units, which essentially are the which once again the code unit are the entries in this Unicode table. And I think this I think we have demystified the initial problem, which was once again, why do these two methods? Oh, not this one. So the initial problem was, why do these two methods in 2 different languages return different results, although we would have expected to have the same result? This video really was an adventure, but I hope things make more sense. For me, at least, they make. And with that, I want to thank you for watching, and I will see you in the next one.